Ironically, all of the conversations that we were listening to were from the kitchen and den areas, which were downstairs. What was even more ironic was that the U.S. Attorney had been conducting meetings at his house since he had some concerns that his offices may have been bugged. He allegedly knew that some secret information was getting out, he just didn't know how. Was the wireless babysitter the source of the leak? Well, we'll never know. But he was clearly transmitting his secret meetings to anyone in the area who also had a wireless babysitter operating on the same radio frequency or had a radio scanner tuned to that frequency. I hope you're getting the message here. Do not use one of these devices unless you want to take the risk that someone else could easily listen in on your private life. By the way, just because wireless intercom and babysitter systems come packaged in an attractive case doesn't mean that someone won't take the electronics out, modify the device, and then use it surreptitiously. I'll share another story with you in a minute so you'll better understand. Now I want to talk about the second type of wireless intercom and babysitter systems that are used to transmit their signals over the power lines. These devices are sometimes called carrier current transmitters, since they use the power lines as an antenna. Now, this video is not intended to be a training video, but an informational one, so I won't go into all the intricacies of radio waves, wavelengths, and frequencies and modulation techniques. Carrier current transmitters use very low frequencies with long wavelengths similar to those used by amateur radio operators to bounce their radio waves off the ionosphere, except they use low power. In other words, it doesn't have enough power to send its signal very far off the antenna. Therefore, by using the power lines as an antenna, the signal will ride down the power line but not radiate its signal any meaningful distance. The primary limitation of a carrier current transmitter is that it can't transmit its signals through the coils in a built-in step-down transformer. These are those big cans you see on the power line or on the ground if you have buried cables outside your home. While it's not that unusual to see several houses share a step-down transformer, it would limit the use by the bad guy to use one of those neighboring homes as a listening post. However, in an apartment community or an office building, the rules are a little different about how many apartments or offices share a step-down transformer. In an office building, several floors may share one step-down transformer. And in an apartment community, several apartment units in the same building may also share one step-down transformer. I know that I'm spending a lot of time on carrier current transmitters, but I'm doing so for a very good reason. They can be very dangerous devices. First of all, they don't use a battery, so the longevity of the transmitter is virtually endless. They are extremely easy to acquire and difficult to electronically detect, unless the TSCM service provider has equipment designed to receive these very low frequencies. Okay, it's war story time again, except this time the husband is the bad guy and the wife the victim. A carrier current transmitter, which was sold by Radio Shack, yes, it even had their name on it, was installed inside the television located in the bedroom. It turned out that the husband had a friend who lived a few doors down who was evidently listening in. Again, I'll let your imagination take it from there. While I have personally never found a carrier current device that did not use the power lines as an antenna, I've experimented a great deal with this type of device and have used both the cable TV's cables and the telephone cables as antennas and have received the signals over a mile away. So beware, these devices can be a very serious threat. Okay, now let's talk about transmitters that are widely sold or at least marketed specifically for surreptitious use. These types of devices can be easily found on the internet and at many local spy shops and typically sell in the price range of $300 to $1,000. What's ironic about these devices is that they're also very easy to detect. That is, if you have someone looking for them. But most, not all, but most transmit in the VHF and UHF radio bands, which are the same as used for two-way radios. And they use the same type of narrowband FM modulation techniques. Many are crystal controlled, which means that the transmitting signal will not drift. And they typically have a range of 1,000 feet or more. And if battery operated, the operating time typically ranges from 2 to 8 days. Many of these devices are packaged into small calculators or ballpoint pens, which can be easily left behind after a meeting. They are also packaged into wall plugs, electrical outlets, and other devices so that a battery is not required, again giving the transmitter a virtually endless life. You will also find remote-controlled and voice-activated transmitters in this area. Remote-controlled radio bugs are a very real fact of life and virtually impossible to detect with radio receivers and spectrum analyzers if the bug is not transmitting at the time of the TSCM inspection. This is why a good TSCM service provider will have a very expensive piece of equipment called a nonlinear junction detector, primarily designed to detect these types of devices. But I'll talk more about that in a later chapter. From my experience, many of the better quality devices are sold by foreign companies, such as the Quarter Spy Shop in London. You should take the time to look at their website to get a better idea of the types of products they sell. As a matter of fact, there's more than just a few companies in England, Ireland, and around the world that openly sell eavesdropping devices. I know that you're probably wanting to see more samples of these types of eavesdropping radio transmitters, but I'm going to let you dig on your own if you're interested. The internet's just full of information. For now, let's move on to the more serious threats that scare even the most sophisticated TSCM providers. Up to now, we've talked about radio transmitters that are relatively easy to buy and relatively easy to detect. When we delve into the world of true economic espionage, where foreign governments use their sophisticated intelligence agencies with very large budgets for designing and building eavesdropping equipment, then we begin to separate the big boys from the rest. The world of foreign espionage has always dealt with the fact that they knew their adversaries had very sophisticated radio receivers and spectrum analyzers to detect their bugs. Therefore, the game was always to develop new and innovative technologies that would fool or confuse the adversarial government who was looking for the bugs. Some of the techniques developed to achieve these goals are commonly known today and commercially used. A good example of this is what's referred to as spread spectrum. This is where the radio signal is transmitted in a very broadband encoded signal. Let me give you an example. If you took the energy of a narrowband radio signal and spread it out, say, 1,000 times, the signal would be very difficult to electronically detect. Of course, the matching receiver at the other end would have to be designed to specifically receive the matching broadband signal. There's a whole lot more than this to what I'm explaining, but I want to keep this simple for you.